Okay, so we're going to start.
Bruno, it's Jim. Sorry to interrupt. I just want to make sure that the slides are showing correctly on the screen.
Yes, for me. It's not full screen. It's up to you.
Okay.
Thank you, gentlemen. I apparently had lost my audio reception, but I'm now hearing you guys. Thank you.
Okay, we hear you back. So we're going to start because we have a full agenda. So you are in the spring meeting. Next slide, please. This is note well. So please note well. This is a set of rules that we need to comply, that all of you need to comply with, including related to IPR disclosure. I'm going to assume that you're aware because this is the third day. Next one, please. So this is the agenda for today. So we have a full agenda. So we're going to ask each speaker to stick to the allocated time slot, which includes both presentation and comments from the working group. And if we have too much or too detailed comments, they will have to be followed up in the mailing list. Any comment or agenda bashing? No. So otherwise, next slide, please. So regarding the meeting, the minutes are collaborative. You can connect and contribute, and also correct whatever you want, including your name and your comments. So you don't have to wait for the minutes to be published. You can correct right now. In terms of queue management, yes, Jean-Claude? In terms of queue management, there is a change for that meeting. You can enter the queue by pressing the raise hand icon. But then you need to separately send audio to speak. And so you have two actions. And please mute yourself when you're not speaking, so that we don't have a background noise. And finally, you need to be aware that sessions are being recorded.
To clarify Bruno's comment about the queue, you use your hand to put yourself on the queue, then wait till Bruno or one of us calls on you, then unmute yourself and speak. We do not control. We will not mute or unmute you unless something goes wrong.
Yes, absolutely. You're the one sending your audio and closing. In terms of working group documents and working status, so we have 5 new working documents. SRV6 Young, SR Policy Young, resource aware segments, segment protections for SRT pass, and BFD for spring. Next one. In terms of working for adoption, we have a call for 3 documents currently. One regarding TWAMP and one with TWAMP stamp. Both have related draft being adopted in code for adoption in IPPM working groups, so related draft for IPPM extensions. You may want to follow that also in IPPM. And we also have a call for adoption for SRV6 pass segment, which is ending in a small week. Next, please. In terms of the future or next working class call, we have first Spring NSH SR. So working class call has been requested by authors. The Shepherd has sent comments on the list, so we are waiting for the feedback from the authors. And next on the queue will be MPLS pass segment, for which the authors have requested a working class call. And I think today some more people will ask for last call. In terms of ISG processing, we have still the SRV6 network programming document, which is progressing, but we still have one remaining discuss from Ben. And then we have the SR Young document, which has just started IETF last call. Next one. So we have another meeting this week, on Friday, at least by Friday, regarding the topic of SR compression for the IPv6 data plane. The whole slot of Friday is dedicated to this subject, and more specifically to discuss the work of the design team. So there is one draft on the agenda, which is the following. So it would be more effective if everyone could read the draft before, so that we can have a productive discussion on the draft, rather than commenting on something else. And one more thing, today on the agenda we have two slots regarding the failure of the segment endpoint of the segment, slot 9 and 10. It turns out that we have at least 5 or 6 documents related to that subject, so where the segment endpoint failed. And probably we need more coordination on that subject, because not all documents are aligned on terminology, framework. And also we could better align between two working groups, because some others are focusing on RTGWG on working group, and some others are focusing in Spring working group, which is probably not going to help for alignment. So we're discussing with the chairs of RTGWG, and one option that we are considering is a dedicated session on that topic. It could be an interim meeting or a meeting for March. And thank you for that. So next is Ketan reading SR policy.
Good morning, afternoon, evening. So this is an update on the SR policy architecture draft. Yes, next slide, please. So this is just an overview of what the draft covers. I believe all the participants are aware of it. Just wanted to flash that slide. We could move to the next one, please, Jim. So this draft has been around for a long time now, and it was also presented at the last IETF with some updates. As we know, it has a lot of deployments and implementations as well. And it's one of the important milestones. There are a lot of other documents in Spring and other working groups that have dependencies on it. So we want to see how we can take this work to conclusion. Next slide. So what are the key updates since the last IETF meeting? And first, I would like to thank the working group for review and inputs for all of them, and they've been on the list mostly, and a few offline. So the main part is the composite. I would think is a composite candidate path construct, and we'll talk about it more in the next slide. Apart from that, there are updates to the SRv6 segment types and SRv6 BSID in this document. This is for alignment with the SRv6 network programming draft, which is now almost through at the ISG evaluation. These changes are related to the fact that we have behaviors which are associated with segments. So we have changes to allow optional specification of those behavior and SID structure for the segment types. And then for the SRv6 BSID as well, we can have multiple BSIDs associated to the same SR policy with different behavior. So we wanted to add some of those clarifications in this text. And then there were some questions about colors and BGP multipath scenario. We just added some editorial updates to clarify those. And then as part of the SRT protection, segment protection discussion, there was an action item to provide some clarification of TI LFA considerations or applicability. So there is just a small text added there based on inputs. And I know there are editorial updates, nits as well on the draft. Next slide, please. So one of the so as I mentioned, one of the changes is the composite candidate path, and let's look at the motivation for this. Today, SR policy has a dynamic or explicit candidate path, right? And let's say that we have SR policy with a dynamic candidate path, and it's has its objectives. So objectives could be, as an example, that affinity to or preference for nodes and links in the blue or red or green plane. And then we have steering of services, let's say P and Q over different SR policies. Let's take example using BGP based steering, so that those service flows stay in the blue or red plane respectively. But then we have some other use cases or new use cases, I would say, where there is a different service that needs steering in a load balance manner over these two different paths, which means, let's say, kind of a 70-30 kind of a load sharing between the blue and red planes. And then similarly, we may have another one which wants a load sharing between another pair of planes in a different load sharing factor. So the objective or the purpose of this introducing this composite candidate path is to provide a solution for such use cases, so that we can have a combination of individual path objectives and achieve load balance steering over them. Okay. Next slide, please. So today we have two types of candidate paths, explicit and dynamic. And here the proposal is to introduce a new type, which is we're calling it a composite candidate path. And a composite candidate path would be nothing but it would include a weight as well as kind of a, let's say, pointer or indirection to other SR policies to the same endpoint with different colors. Like we saw in the previous slide, color 1 would mean blue plane, color 2 could mean red plane. And this is to allow kind of a combination in a flexible manner of the intended objectives. Want to stress or highlight that the unit of signaling from protocols, BGP, PSAP, and even from a model perspective, Yang model perspective, it would kind of remain the candidate path. And overall, the rules of selection of the candidate path, the preference, that which one is active, and the overall framework of SR policy is not really changed. So we've had some discussions, welcome feedback and inputs on this as well further. Next slide, please. As part of this composite candidate path, there have been discussion on color usage and how it is managed or how it should be managed. Today, all SR policies have color associated with them, right? It's part of the identification of the SR policy. That's color and an endpoint. And draft has different steering mechanisms over SR policy. Those based on BGP leverage this color. There are other mechanisms like BSID which do not leverage the color. And then there are other mechanisms in the draft which may or may not leverage or use color. I would say that these may be implementation specific mechanisms that may be there. So a discussion point for the working group has been, do we allocate or reserve a separate block for colors, as has been requested by some members, or do we allow the operator to manage this color space based on their deployment designs, also leveraging whatever is available to the implementations that they are working with. So this is something that we look to get inputs from the working group. Next slide. So I believe we are progressing well towards working group last call, and would like to check with the working group if we believe we are ready to go there, or how we can get there.
Tarek?
Yes. Questions? Yes.
Tarek,
Can
you
you-
can mute yourself.
This is the Tarek with Juniper Networks. Can you hear me?
Yes, Tarek.
Oh, can you go back to slide 7, please, Kedam?
Jim, the previous slide. Yeah, thank you.
Oh, okay. So this is about the block allocation for dynamically instantiated SR policies. We've had exchanges on the email about that. I am in favor of allocating a separate block for dynamically created policies, a separate block of colors, I mean, for those dynamically created SR policies, specifically when they are created by a controller. I'm not sure you want to throw the onus on the operator to manage such blocks from the many headends they have in the network. It will become cumbersome. So eventually it has to be learned dynamically, maybe via PSAP or some other protocol. I just wanted to sound this out. I know we have had exchanges on that. So.
Okay. Sure. And the motivation for that would be, Tarek, if you could clarify that, what would you see as the concern if we were not to do that?
Yeah, so the idea is for hierarchical SR policies that were introduced. I don't know if you're hearing me right now. You are?
Yes.
Okay. The hierarchical SR policies that you introduced, I think there are on the previous slide 6, or maybe I'm not sure. I'm not keeping track. Where you presented those with color 1 and color 2. If you can flash that again, it might help.
Okay. So basically, what you're saying is there are some that which do not use, or operator may not wish to use them for steering based on color, right?
Indeed.
And there are other mechanisms like BSID also. So you're saying that for such, you would like to have a different color, right?
Yeah, the tactical key is the BSID. I did mention that, and the other one is the hierarchical policies, as we talked, right?
Okay, sure, Tarek. Thanks. I think we can we'll look for more inputs and take it forward. Thank you.
No problem.
Shraddha?
I'm Shraddha Hegde from Juniper Networks. Can you hear me?
Yes. Hi, Shraddha.
Yeah. So regarding the composite candidate path, so we are introducing one more level of ECMP, right? Which is hierarchical. Like we already had an IGP ECMP and a per segment list weighted ECMP, and this is one more level of weighted ECMP, and on top, like if there is a BGP service resolving which has multipath enabled, then that will be the next level of hierarchy for the ECMP. It's possible that some platforms may not be capable of doing so many hierarchies, and it will be good some text can be written what should happen in that case.
Right. Thanks for bringing that point, and I completely agree with you there, Shraddha. This hierarchy that we're talking about is actually more like from a conceptual or a framework perspective. How the draft does not talk about how they get manifested in the forwarding. But if you would like some text to be added, may I suggest that you propose some text and we can discuss offline or on the list, and
Sure.
we can definitely add it. Yeah.
Yeah, sure.
Thank you.
Sheng?
Yeah, I have a comment of the composite candidate path as well. For me, you introduced a new kind of candidate path. It's good, but it's a little bit hard to understand, and I could like you can add more text to describe it. And also, do we really need to specify that the the endpoint of the uh, composite candidate path should be identical? Must be identical. I'm not really sure about that.
Yes, because otherwise, they are. It would be kind of. I mean, I think it would be very odd, right, to have them go to different endpoints. It would not fit under the in the hierarchy, right? Uh, so maybe I'm not getting maybe the point, and we can sure perhaps discuss off the list more
Yeah,
details.
yeah, sure.
And yeah, and please do suggest or propose text for any more clarifications that you think we should add in there for the draft.
Yes, thank you.
Thank you.
Noise?
A very short comment about separate colors block for non-BGP cases. I think it might bring additional complexity because it will require like color negotiation, etc. So from one side, it could be helpful, but from another, I think more complexity in this case.
Sure, but I think I mean I think we have opinions on both sides, and we can work out the consensus or how to go about it on the list. I guess that better. Thank you. Okay, thanks, Tim.
Okay, so in terms of last call, maybe we need sometimes to discuss the new additions in terms of color on the
Yes,
new candidates.
we should wait for these conversations to reach a consensus, and then
Then we'll do last call.
New Year, yeah, perhaps.
Thank you, Ketan.
Thank you.
Next is Rudiger. Rudiger? Okay, thank you. I'm not hearing you.
And the idea here, suggestion is to apply segment routing as an additional MPLS trace route option to lower the total number of end-to-end LSP validations as compared to commodity MPLS trace route. There's a little text on what are the frameworks. Clearly, if there is a high number of ECMP paths, then the suggested method leads to a better usage of the forwarding addresses, which are used to validate the paths. If ECMP is present, it kind of filters out addresses which go to a part of the network. And well, I'd suggest to go on to the next slide soon. There are two things I'd like to learn from vendors if they have implemented that independently. We are applying that for LDP, MPLS in Deutsche Telekom. Segment routing isn't operational, so I didn't check whether this has been implemented by some of our vendors, and there are more out which are not operational in Deutsche Telekom. I just would like to know the idea is not that that creative that others can't have it. If there are implementations already out, our operators like the functionality. That is something that I can tell. Okay, then please switch to the next slide. Right. This is an example, and it calculates some paths. There are 4096 available by all the interfaces and the parallelity. Just think about that. The network shown is also symmetric on a lower part, which I didn't include in the picture. And then if you start an MPLS trace route with 32 multipath IP addresses, of course, already behind the source router on the left-hand side, half of them go to the lower part and half of them go to the upper one, expecting ideal ECMP. And at router 110, you have left 8 IP destination addresses, which would go to the 8 interfaces to router 121, and another 8 to 120. And ECMP is not an exact method. The result will be that some interfaces will see 2 IP addresses being routed across it, and others will see no IP address being routed. So what happens in RFC 8029 or RFC 8287, maybe, trace route is that the source router will start to measure with another 32 IP addresses, and you will have the same effect again, and only 16 will go to router 110. This increases the likeliness that you can pass it, but you will have the same problem likely if you arrive at R120 with 14 or 15 IP addresses only. Then the next 12 interfaces connecting R120 with R130 might also be difficult to address them all. So in operations, you will see what I'd like to call gray interfaces, which you cannot address. And then you will have to start again from RS with another set of addresses. And as far as I can tell, our staff continues to tell us that, yeah, in some cases, you cannot address or test all interfaces from a router start to with a trace route to router destination if you use ping as it is. And the idea, which is shown on the next slide, please, is to add segment routing functionality. And that would allow you, if a router source on the left-hand side adds a top label, like, for example, the node SID, the S is missing, node SID 110, and forwards a packet to 110 by segment routing, and that packet is a simple commodity MPLS OEM packet with, of course, corrected round trip time, stuff like that. Not round trip time. Okay, I'm a bit tired. Sorry, but the time to live has been set correctly. Then you can forward up to 32 IP destination addresses to that router. You can ignore ECMP stuff and enable IP packets with a full set of destination addresses to reach the router. And that can be done also repeatedly. You could do that with a packet sent to R120 or R121 if that is of interest. What you need to do here is we do not need any new protocol components. So MPLS OEM can stay like it is. This is a local improvement on routers. You, of course, need to adapt the implementation, and you need a different state engine inside of the routers. We have implemented that, and our operators like it. That is it. If there are comments, please go to the list, and I'd also appreciate if vendors have implemented that already to talk to me, of course, because I'm not sure whether I'm the only one. Right. Yep. This is an individual draft. If you like the idea, yeah, please speak up, give a discussion so that the work can be picked up if you like it. Thank you very much. If there are questions, of course, I'm happy to answer.
Thank you, Rudiger. Maybe if you have specific questions, you can send it on the list. And eventually the replies could be private if it's implementation or roadmap specific.
Sure.
Could be an idea to kick off the discussion. If there are no other questions, we can move to agenda for generic TLV.
Hi, can you hear me?
Yes.
Okay. Hi, I'm Nagendra from Cisco. So I'll be presenting this draft on behalf of my co-authors. Next slide, please. Okay, so let me start with the problem that we are trying to solve with this draft. So currently, I'm sure you have noticed there are different types of segment IDs that are proposed with different forwarding, instruction or forwarding semantic associated to these segment IDs. So when this segment routing is applied on MPLS data plane, we are actually extending and leveraging the machinery defined in RFC 8029 for the OEM purpose, like path validation, trace route, etc. So in order to do that, one of the primary requirement right now, as per RFC 8029, is to define a new target FEC stack sub TLB for each of the segment ID. So this is more like a one-on-one kind of mapping right now, where for each of the segment ID, we define a new target FEC stack sub TLB with its own definition. So this requires basically a lot of effort and standardization, and also either a domain-wide or a node-wide software upgrade, so that the initiator and the responder can understand what sub TLB is it. They can pass the data included, perform the FEC validation, and respond back with a positive or negative response. This basically raises scalability challenges. Can you go to the next slide? So this is a partial list of some of those SR effects that are defined recently. So we took a step trying to define the standards or define the new sub TLBs for these SR effects, including the flex algo. And we started noticing that there seems to be a plethora of new segment IDs that are coming up, and it may not scale if we were to come up with a new target FEC stack sub TLB for each of these segment IDs. Next slide. So it's not only about the standardization effort or the upgrades, but also the amount of information required by the initiator to be included in the probe or the sub TLB in the OEM probe, and also the amount of information that needs to be processed and need to validate basically the fix, so that the responder can reply back with a positive or negative response. Next slide. So we took one step back. Instead of blindly defining new sub TLBs, we thought if there is any scalable way where we can try to address this challenge, and that's what we did with this draft. So instead of defining one-on-one basis kind of segment targeted FEC stack for each of the segment ID, we tried defining one generic segment ID that could be applied to validate different types of segment IDs. So as part of this, what we did is we proposed a new sub TLB that only carries the segment ID that needs to be validated. And from the validation, the FEC validation point of view, there are two main things that basically any responding node will do. So whenever the probe reaches the particular node, the responding or the validating node will perform two basic check. One, is it the LSP endpoint for that particular segment ID? And did it receive the probe on the right incoming interface? So by performing this basic two validation, we were able to validate different types of segment ID using just one single generic SR sub TLB. Next slide, please. So this is the sub TLB that we defined in the draft. As you could notice, it simply will carry the 20-bit segment ID that needs to be validated. Next slide. So we included a couple of examples to explain how this sub-TLB could be used for validating different types of segment IDs. So in this scenario, this basically include both the prefix set for both the default algorithm and also flexible algorithm. So let's take an example where node 8 is assigned with prefix segment ID of 160008 for the default algorithm and 161288 for the flex algorithm, algo 128. So the node 1, when it wants to validate any of these prefixes, let's assume that it wants to validate 160008, it simply will include this segment ID as part of the sub-TLB in the MPLS OEM probe, the request, and one will send the traffic. When node 8 receive it, like I mentioned earlier, it performs two basic things. Is it the LSP endpoint for 160008, and did it receive it on the right incoming interface? So depending on how the algo is enabled, in case of different interfaces for different algorithm, or if both algo are enabled on the same interface, it can validate if it is the endpoint and if it received the probe on the right incoming interface. So based on this, node 8 will respond back to node 1, which is the initiator, with a positive or a negative response. Next slide. So this is another example where the same machinery can be used to validate the adjacency set. So in this case, node 7 assigned parallel adjacency 9, which is 9378. So node 7 can load balance between link 1 and link 2 to node 8 when the topmost segment ID is 9378. So in this case, when node 1 want to validate 9378, it simply will include this 9378 in excuse me, in the MPLS probe and will steer the traffic. And when 8 receives it, again it performs the basic 2 check. Am I the LSP endpoint, and did I receive it on the right incoming interface? So in this case, 8 can receive the traffic when 9378 is the adjacency segment. It can receive the traffic either on link 1 or on link 2. So as long as these two basic validation are checked, node 8 will respond back with a positive response. And if any of these fail, it will respond back with a negative response. Next slide. So this is another example for parallel set where instead of terminating both the links on the same node, we are actually terminating it on different nodes. In this case, 9378 is load balanced by node 7 to node 8 and also node 88. So again, the same procedure can be applied here, and as long as we are terminating it on the right interface, we'll be getting a positive response. Next slide. So one thing I was kept telling is like one of the check to ensure that basically as part of the validation, one of the things that we do is to ensure that we are receiving the probe on the right incoming interface. To do that, we basically introduced this. Again, this is a local implementation matter, but we included this one approach as part of the draft where each of the node can maintain a table, which is a segment ID to the interface mapping table, which could be easily used to perform the check if you are receiving it on the right incoming interface. So in this table, each of the node will have all the local prefix sets along with the respective interface. For example, if it is a prefix set that is associated with the default algorithm, then it could be it can receive the probe from any of the incoming interface. But if it is another, so it also includes the adjacency set assigned by the directly connected nodes for itself. So in this case, node 8 will include its prefix set for algo 0 and also algo 128, and it also includes the adjacency set assigned by node 7 for 8. So you could notice that we are not required to maintain any other details, including its own adjacency set or even the adjacency set assigned by node for 5 or 6. All it needs to do is include the adjacency set assigned by the directly connected nodes for itself. So using this table, we'll be able to validate if you are receiving the probe on the right incoming interface or not. Next slide. Yeah. So in a nutshell, what we are trying to do was define one targeted FEC stack that could help us validate multiple types of segment IDs. So one, it of course drastically reduce the standardization effort. So we don't anymore need to have a one-on-one mapping for right now for each of the segment IDs. We don't need a targeted FEC stack. And two, we drastically reduce the number of or the volume of information that needs to be included by the initiator, and also the volume of information that needs to be validated by the responder. And it could be easily extendable to accommodate any future segment IDs, as long as we're able to use those basic checks. Next slide, please. Yeah, so this draft request one sub TLB allocated for TLB type 116 and 21. So we're not requesting any new written code or written subcode. We are actually reusing the one that are defined as part of 8029 and also RFC 8287. So this draft doesn't request any new written code or written subcode. Next slide, please. Yeah, so we have this draft presented in MPLS during last IETF, and we'll be presenting this in this IETF as well. So we welcome any feedback. We strongly encourage the group to read this draft and share your comments. Any textual contributions are always welcome, and we'll be requesting the MPLS chairs for work group adoption soon.
Hear
me now?
Yes.
Okay.
Yes.
How do you handle the anycast sits, and is there any procedure that you recommend that the initiator, when it receives multiple replies, and if some reply doesn't come in, how do you handle that?
So in case of anycast, we are not going to replicate, right? So we're not going to receive it from multiple responses. Unlike the P2MP, in case of anycast, we are going to terminate it on the nearest address or node. So I think we won't be expecting multiple responses.
One question. So, like here, does it mean that we just need like one bottom flag to be validated at the far end, or we still need like a stack of other flags for each segment?
So it depends. It depends on what you want to validate. If it is multiple flag that needs to be validated, then we may need to include more than one. But if it is just the bottommost flag in case of ping, then we just need to include the bottommost one.
Okay, thanks.
Okay, thank you, Nagendra.
Yeah, thank you.
Next is Shradha for seamless SR routing.
Hello, can you hear me?
Yes.
Yeah, so I will be presenting updates to the Seamless SR draft on behalf of my co-authors. So this was presented in the last IETF, and we will go through the updates to the draft. And next slide, please. So, and we will also see one of the use cases, how it is solved using Seamless SR, which is the end-to-end low latency use case. Next slide, please. So these are the updates on the draft. So we added details on how inter-domain flex algo can be realized with BGP-CT. Basically, if you have multiple IGP domains and each domain has deployed a flex algo, so BGP-CT can be used to interconnect these, and the flex algorithm number can directly map to the color, and that color can directly map to the transport class route target that is carried in BGP-CT, and that's how you get an end-to-end connectivity for that particular flex algo. So the other detail that the next detail that we added is about color-only policies. So let's say there are two domains. Both are deploying color-only policies. So from one domain, the color-only policy can be advertised in BGP-CT to the other domain, and so that you get an end-to-end connectivity for this particular color-only policy. So in the BGP-CT, the in the NLRI portion, the prefix will be 000, and the color will be encoded in the route target. And there will to be able to advertise multiple of these color-only policies, the route distinguisher enables advertisement of these multiple color-only policies end-to-end. And we added some details on the use cases and examples explaining how these use cases work. So one is this data sovereignty use case. Another is interconnecting IP fabric DC use case. So basically this use case talks about if you have to create diverse paths across two DCs, how that can be done using BGP-CT. So the next update that we added is translating transport classes across domains. So imagine there are two domains where the colors do not match. Like for example, red color in one domain has a different meaning in another domain. So, and that maps to the red color in one domain maps to a green color in the other domain. So this could usually happen when these two are cooperating domains. It could also happen if it's a result of some network mergers. So an example has been added, to explain how exactly this translating the colors across the domain works. Basically, the idea is the NLRI, which is the prefix and the route distinguisher, remains same, and the route target changes across domains to appropriately use the transport tunnels which map to the required intent. So we also talk about automatic creation of transport classes. We have some details in the next slide. So for details of all these updates, please go through the draft and let us know if you have any comments. Next slide, please. So automatic creation of these transport classes. So BGP-CT is very similar to BGP-LU, right? It runs on the border routers, and then it has this route target which corresponds to this transport classes. You would require these transport classes to be configured on these border routers. This is this automatic creation of transport classes explains how that configuration can be avoided when you have the transport tunnels that with color that maps directly to these transport classes, which are in turn translated into the route target in the BGP-CT. So it's kind of greatly simplifies the operations, having this automatically happen. So the first case is when the transport tunnels are based on BGP SRTE. So there is this 32-bit policy color in the SR policy NLRI that translates to a 32-bit transport class route target. Similarly, when the transport is based on FlexAlgo, the 8-bit algorithm translate to 32-bit transport class route target. And when it is on when the tunnels are created based on PSEP, the 32-bit color in the SR policy identifier TLV that translates into a 32-bit transport class RT. So once you have the tunnels created with any of these mechanisms, and you have BGP sessions created across your borders, and you enable this new family, then you can automatically get end-to-end tunnels by this with use of this automatic creation of transport classes. Next slide, please. So here is the use case on how can we do end-to-end low latency with using this seamless SR approach. So imagine we have these metro core, metro domains, different IGP domains. So intra-domain low latency paths, they can be calculated using any of the intra-domain tunneling mechanisms such as FlexAlgo or SRTE or RSVP. So the problem is to find lowest latency path from PE2 to PE6, which spans across multiple domains. So the solution is to define a low latency transport class and then use this intra-domain, accumulate this intra-domain latency metric in BGP. So there is this draft IETF IDR performance routing. This defines a new latency metric sub TLV in the AIGP attribute, accumulated IGP attribute. So this accumulated latency metric works very similar to accumulated IGP metric. That is, instead of IGP metric, it accumulates the latency metric. For example, in this rightmost metro, the latency metric is 10 for the lower path, and for the upper path from ABR 7 to P6 also it's 10. And when the BGP advertises this from ABR 8 to ABR 6, in the bottom path, it will add the latency metric of 2, which corresponds to that latency for that link ABR 6 to ABR 8. Similarly, the bottom path, the latency is 5, so that adds on to this latency 10 plus 5, then becomes 15. This continues on every border router. The latency keeps getting added onto the existing latency. And when you receive on PE2, on the ingress, when you receive both the advertisements from ABR1 and ABR2 for PE6, the advertisement received from ABR1 has the latency metric of 42, and the advertisement received from ABR2 has a latency metric of 36, 35. I don't see the slide now.
Yes, Jim, we have lost the slides.
So I can continue. So basically, what happens is when these two latency metric is received, similar to how the AIGP metric is used for BGP best path selection, in a similar way, this sub TLV from the accumulated latency metric is used for BGP best path selection, and that's how the lower path, which has lowest latency metric, gets chosen. So that's pretty much we had. So I had request, review and comments from the working group, and also request possibility of working group adoption.
Quick apology there. I lost my internet connection for a couple of seconds, but back now. So sorry I didn't switch the slides there.
Thank you, Jim. Ketan?
Ketan Talaulikar, Cisco. Thanks, Shraddha, for the update. The draft, as I believe, has actually 3 parts or 3 components. It goes into use cases, it goes into requirements, and then it has a proposal based on BGP-CT. And I believe for the problem statement, there are several solutions available. I'm sure you are aware of things like hierarchical PCE and other flavors and options. I'm not sure if there are informational drafts about that out anywhere. My question would be, would it not be better for us as a working group to first look at the use cases and the requirements, and try to work on them, while we have already solutions that are this and other solutions that are already under development.
Ketan, yeah, so the requirements and the use cases, yeah, definitely we can look at them and discuss them. So this, I believe, the proposal is a different solution than the existing solution. So it's using BGP-based mechanism to interconnect multiple domains. As far as I understand, the existing solutions are mostly label stacking solutions, which do not use BGP as a BGP as a mechanism to interconnect multiple domains. So this architecture is mostly an extension to the existing seamless MPLS architecture, and mostly trying to create multiple, bringing in the ability to create multiple colored paths end to end.
Right. I mean, I understand this thing. My point was that there are these requirements. There are the use cases, and I believe all of this work is informational, because this is all about design. Seamless MPLS was also informational. So my suggestion would be that as a working group, we tackle the requirement and use case first, and try to capture what is there, plus so that it's not that there is only one solution that's available there. The working group should, if we are documenting solution, we should have other solutions also documented.
Yeah, that's a fair point, Ethan.
Yeah. So I mean, we can collaborate and discuss further offline. Thank you.
Yeah.
Norris?
Sorry, just one comment. I think in introductional part, more comparison or differentiation is needed with BGP LU, because currently there is just one sentence, what this solution is better than BGP LU. So I think more comparison is needed about this.
Yeah, sure. I'll add more text to the draft, just for information. So BGP LU, it could give a best path from, like, you want to go from PE1 to PE6, which is residing in another domain. BGP LU could give you a best path. That's one single best path. And here we are adding the ability to, create multiple paths, one green path, one red path, and one blue path. That's the at a very high level. Yeah, but agree, I will add more text.
Ron?
Replying to Ketan's comment, I think we're looking at two distinct requirements here. One requirement is for coarse-grained TE between networks that value autonomy. Another is for fine-grained TE between networks that are much more tightly coupled. So I think that this draft should probably go forward, satisfying the first requirement.
Yes, Ron, that's a very valid point.
Can I respond?
Yeah,
I think that was entirely my point, is that we need to have this clear or better understanding of the requirements in the working group. That was my point. Yep.
Charity?
Can you hear me?
Yes.
Also responding to Ketan, I would say that if this document is targeted as a standards track document, then having a solution would be important. Having a requirements document would be important so that we are not coming up with too many solutions for the same problem. Given that it's targeted right now as informational, I think it's fine for it to set out what its goals are and set out how it wants to achieve those goals. I think the overhead of writing a requirements document is probably not the best way to deal with it. The other thing I'd like to point out is that we've gone over the whether we should have hierarchy or not, and hierarchy has a lot of good sides to it, which is you do information hiding. You don't blow up any one domain, or in the case of hierarchical controllers, any one controller. At the same time, you lose granularity, you lose end-to-end visibility. So there are trade-offs, and it's not the case that one solution will fit all. So I think if you have two different approaches, so long as they're not standards, it should be a fine thing to document both. Thanks.
Thank you, Kiriti. Uma?
That is a great presentation. I read the document and I strongly feel this should be adopted. I think it's very useful thing that you documented both use cases and requirements and the solution, the possibility of how to implement this. The way the seamless MPL is used in backhaul, there's a huge potential for this, and I really support this. Thanks.
Thank you, Uma.
Thanks, Uma.
Kiran?
To Kiriti, I mean, I agree with all that is said in substance for sure. This draft is currently marked as standards track, so that was one part. The other part is that we definitely want to present all the choices and all the solutions, and therefore it is if we are doing informational documents for the solution, then as a working group we should try to present the various options so that operators can make the choices. I still feel that there is a value to have a requirements separately discussed and worked on in this case, because it would again help whoever is looking at those informational documents to kind of have a reference point to compare the pros and cons for their specific use cases.
Okay. We're going to close the queue after Kiriti and Ron, and just as a reminder, you don't have to restate the points you've made before. Kiriti?
I want to get out of the queue. I didn't mean to stay on. Sorry.
Welcome. Ron?
A solutions document is all well and good. However, we shouldn't make the solution document block on the requirements document. I'm sorry, I said that wrong. It's all well and good to have a requirements document, but we shouldn't make the solutions document block on it. We have some bitter experience where we have solutions blocking on requirements documents for ridiculous amounts of time, and we don't want to repeat that experience.
Okay, so we're going to try the new tool. We're going to do a show of hands. So who have read the document? And if you have read, do you believe it's a good start? Sorry. If so, raise your hand. If you believe it's not a good start, do not raise your hand explicitly. I mean. Okay, so we have a fair number of people who have read the draft, 22%, on diverse opinions. So we would welcome more discussion on the list. But if the main discussion is to, I mean, a discussion on the subject, if the discussion is what mostly about splitting the document in two or not is something that we can discuss later. By two, I mean requirements and solution. But I would welcome some discussion on the solution being proposed. Thank you. Next is Zafar for IOM.
Hi, can you hear me well?
Yes.
Oh, great. Many thanks all. I will be presenting this draft on IONM encapsulation in SRv6 network on behalf of my co-authors. Next slide, please. So this draft has been around for quite some time, since October 2018. It was first presented in NPS working group around November 2018. Since then, there have been multiple presentations to IPPPM and 6-pen working group as well. Next slide, please. So the draft really takes how we can carry IONM define encapsulation in SRv6 network for the use cases, for example, that IONM data collection from a TE part, where the focus is to get the data from the endpoints, segment endpoints only, and not all the transit node in the network. Because in TE part, a lot of times the segment endpoint have very specific topological behavior. And because also IONM data collection on a hop-by-hop basis is expensive process in terms of the hardware resources and MTU usage on the packet. So this is a very sweet spot to collect the IONM data from the segment endpoints and not all the nodes in the network. So that is the focus. Now, IONM data fields encapsulations that can be carried in various protocols like NSH, Geneve, IPv6 hop-by-hop header, IPv4, MPLS, and here we're talking and focusing on SRv6 and the data collection from the endpoints. To achieve that, IONM encapsulated packet, as the encapsulation is not defined here, because we use encapsulation for IONM that is defined as draft IETF, IPPPM, IONM data. But carry that information inside SRH, within the SRH TLV. The draft defined procedure for ingress node, how we achieve this, the segment endpoint node, and the egress node. And we're going to go over this. And the draft does not introduce any new procedure or IONM encoding, which is as defined in IPPPM. Next slide, please. So let's talk about the procedure for the ingress node. So ingress node, based on the local configuration associated with the policy or any other SRv6 encapsulation, may decide that I need to monitor and collect IONM data from all segment endpoints. In that case, implementation on the ingress takes well encapsulation SRv6 header, decide and will add a pre-allocated SRH TLV in the packet. And the pre-allocated SRH TLV is also deterministic in segment routing network because the segment list is known. So you know how many points are there in the network. So that's an advantage, is deterministic. And then the endpoint node, based on local configuration again, may insert local IONM data as the packet leaves from the ingress node. Next slide, please. At the endpoint, which is the transit node, so all IPv6 transit node we ignore because this is typical IPv6 forwarding. So not look at the SRH or will not add the data. The segment endpoint node, where the destination address is set to a local state, will determine that there is a TLV and if a local configuration on a segment endpoint node allows to do IONM data collection, then only that node will look into or find the presence of the SRH TLV based on the segment list or segment left field, determine the offset at which it should be recording the IONM information, and then forward the packet to the next segment. So this will happen segment by segment basis. Next slide, please. The egress node behaves very much like segment endpoint node because it has a local SID and it is processing the local SID, and that local SID has a behavior that, okay, I'm allowed to do the IONM data collection and transport, and at that node will then, as part of the processing, will look at the SRH TLV, process will add the local data as the requested segment or as the requested offset based on DSL, now SL is 0, and then send the packet off for a telemetry collector which is configured telemetry collector. So that's in a nutshell what is this procedure. Next slide, please. So there are a couple of things. One is that we would like to get working group feedback on this draft. We are also priming this for working group adoption, so we welcome all the question and comment. One question for the chair would be that we believe that the work should happen in spring. It doesn't change any encapsulation for IPPM. The draft does not change the SRH TLV. It uses as is defined in RFC 8754. So it's a simple use of what is already defined for SRv6. Any question, please? Many thanks.
So, as I understand, you are describing how to use IOM trace options.
Yes, how to use IONM trace option there, yes.
Yes, so IOM trace options is only one way to collect and transport the telemetry information collected based on IAM namespace ID and IAM trace type. So in IPPM working group, there is a working group draft that's called Direct Export, which basically does not require any information being stored in the packet, in the IOM packet itself. So this information is exported, as name suggests, directly from each node that generates their information to a collector. In my opinion, that method of collecting and transporting telemetry information has a number of advantages. Also, in IPPM working group that we had meeting Monday, we discussed there is another proposal on hybrid two-step method, which is a combination of IOM trace option and direct export. So basically what it creates a follow-up packet which is out of band, which is again advantage similar to direct export. So their network resources, especially for services critical to delay and packet loss, does not require more bandwidth, because in IP trace options, in IOM trace options method, the telemetry information consumes the bandwidth of the network because it's in band. So have you considered this other out-of-band methods to collect information, and what you see as advantage of IAM trace option?
So I agree that out-of-band collection or direct export is a definite method that in some cases would be preferred. And in fact, there is orbit behavior also in SRI that is defined along the same line to do an out-of-band export of the packet from the segment endpoints. But that does not change the advantages of doing the data collection in the packet. We cannot be deciding that one way or the other. One way is better than the other, because in direct export, the problem is the correlation of the packets at the controller, because you have to collect these copy of the packet from everywhere and then correlate. So there are pros and cons. And this is why, I mean, there are two methods that are defined. And what you propose for the hybrid two-step is very interesting proposal. And I think is also sort of orthogonal in terms of we cannot, like, in defining solution, we cannot be cherry picking one versus the other, because they both have their own space and advantages. Here, the advantage is that we are collecting data only from segment endpoints, which are important nodes, and we are collecting only if the node supports the data. And because we are deterministic from the behavior point of view, and from pre-allocated space point of view, so the MTU issues and a lot of other issues are addressed in that case. So I think it is simple. It's also a very sweet spot for SRv6 network. That's how I feel it. But we're not suggesting that direct export should not be done or one way or the other.
Actually, it's interesting. So you brought their MTU, and I think that MTU is a more concern for IOM trace option, because you have to control the number of nodes that generate telemetry information, and amount of telemetry information, because otherwise you may exceed MTU size of your data packet. The advantage of direct export and hybrid two-step that there is no limit, because I can hardly imagine that the node will generate more information in a direct export mode more than MTU. And hybrid two-step allows to generate a sequence of follow-up packets from one packet, and actually it collects them as it follows their IOM packet, so there is no additional information required for correlation. As for challenge to do correlation with a direct export, yes, you are right. It requires additional information to being collected from the node, so that correlation of information can be done by the collector. But again, there are trade-offs, but I believe that out-of-band methods to collect and transport telemetry information have to be seriously considered, and I cannot agree that we should not recommend and champion methods that we believe are better suited for the network.
So coming back, just one answer, if I may, Bruno, and then we can stop if you like. What I meant to say is that because segment lists are deterministic, fewer nodes, and known to the node that is encapsulating the packet, the MTU size and data amount is deterministic. So you don't run into a lot of problem that you would run otherwise for the IONM tracing in the data packet. So while I'm not disagreeing that direct export is a very good viable option, I'm also saying that this method provides a very sweet spot for in-band tracing in the packet.
Okay, so we're running out of time, so we're going to cut the queue. Greg, if you can start a thread on the mailing list to discuss the trade-off. on Ron? And Ron and Zafar or everyone, if you can.
Sorry, I took much time. Yeah.
Yeah. If you can focus on a clear, a short answer, if it's possible. Ron, sorry.
Okay. First, I agree with everything that Greg said in the last comment. Second, I have some questions about your reliance on the SRH TLV field. It's clear how this would work in the situation where the SRH is the only mechanism you're using for traffic steering. It contributes a little bit to SRH float, but at least it's understandable. It's not quite clear how this would work if you're using the micro-SID for traffic steering. When you hit a node that's specified in the micro-SID, would you have to look at the SRH anyway?
So that is the behavior part, and that decision is based on a local determination on the field, on the SID that is being processed at intermediate node. If TLV is present and is allowed for that node from a local configuration, then yes.
So even though you're routing through a micro-SID, you'd still look at the SRH.
Yes, SRH, TLV, and all the other parameters are equally applicable to the microsegments.
Mm-hmm. Okay.
I may have a follow-up question because in the draft you use SL segment left index, and with microSID it would be different. But we can follow up on the.
Yes, I think we can follow up.
Yes.
But the scope, yeah, we can follow up on this.
You said.
Yeah, hello, this is Giuseppe. I have a question regarding the relation between this draft and the IOM IPv6 option draft, because I guess that the same effect can be, you can achieve the same effect by using the destination option header together with the SRH.
So I think we can take it offline, but one point is that with the IPv6, especially with the hop by hop option, when you use hop by hop option, you collect data from all the hops. And in this use case, we are trying to collect data for the segment endpoints only. So that is the major difference, that the data collection is from a fewer places, is more deterministic in terms of how many segment endpoints we have. But we can take it offline.
Yeah, no, I mean, because we had similar discussion in 6 months, and in the end, yeah, you can have the same effect to measure for each segment if you use the destination option header together with the SRH. But anyway, we can take it offline, no problem.
Sure.
Zafar, are you presenting to 6 months also?
I have presented this to 6men a few times already, like at least a couple of times.
That would be the kind of discussion which is better suited for 6 months.
Yeah, and this goes back to my question also, Bruno. That
yes.
But I think this would be a good. At the moment, I would like the chairs to discuss this with 6-man chairs and IPPM chair in terms of the proper home.
We have started the discussion with 6-man chairs. Andrew.
Thanks. I just wanted to ask that since there seem to be multiple methods of doing this, would it not be useful to have a fully defined requirements document so that we can then look at the requirements vis-a-vis all the other solutions and then work from there? Thanks.
Yeah, so there's a lot of work in IPPM for the work is done in terms of all requirements as well as I think framework as well. So IPPM working group for IONM has worked on all of those things before defining the encoding. And here is the draft really uses the encoding which is already defined by IPPM and use it for segment routing network, for SRv6 network. So, I mean, we can discuss it offline in terms of what exactly you would mean, but I think the scope, what you're asking for requirement and other aspects is IPPPM would be better suited place for that discussion. And I think that work is done there already.
Thanks, Young. Young, we do not hear you.
Okay, can you hear me now?
Yeah.
Okay. Quick question. So, is there TLV allow us to like skip some segment? So because like each end of segment endpoint processing the data may interference the metric. So if we allow to like do incremental like measurement, so that we'll get like, more accurate data.
If your question is like if the RFC 8754 mentioned that TLV processing is only based on a local decision or local configuration data at a segment endpoint node. So a segment endpoint node can skip based on a local decision, based on not capability also, or because based on a local decision, policy decision, not to even look at the SRH TLV. So it's very well defined.
Yeah, so the concern is like, can we allow the head end to control this, so that you know, so we can get a end-to-end accurate measure, like a telemetry metric.
You mean head end controls which node will send the data?
Which like head end said, okay, I like measure like from the segment 1 to segment 5. I want to skip like a segment like 2, 3, 4.
Yeah, I think we should discuss this offline a bit,
okay,
because I think the local decision point is very clear, but from head end control, we should discuss it offline.
Okay, so we have a lot of comments. It would be good to start multiple threads on the mailing list regarding what information we need to send, how, was it inbound or outbound, how to encode in the packet. So please start the threads in the mailing list, either the authors or the one commenting. Next
Thank you, many thanks.
Email for point-to-point. Thank you, Zafar. We are a bit late on the schedule, so eventually we need to move one slot to Friday. But for everyone else, please consider the timing.
Can you hear me?
Yes.
So I'd like to present this draft of a P2MP transport using chain on behalf of this group of co-authors. Next slide, please. So to do P2MP transport in segment routing, there are traditionally two methods. The first one is ingress replication. It uses the P2P tunnels. It's stateless in the core, but there's no traffic optimization. The second method would be a controller-driven P2MP tree. This can achieve a maximum traffic optimization, but it also introduces a P2MP tree state on every branch node, so the core become stateful. So in this draft, we consider two fundamental principles of segment routing. One is stateless core, and second one is the second one is single point provisioning on ingress routers. So based on that, in this draft, we're proposing a new mechanism for building a stateless P2MP transport. We use a new type of tunnels called the P2MP chain tunnels, or simply P2MP chains. Each P2MP chain can reach multiple leaf nodes along the path. It is provisioned only on the root node without involving any transit routers. So with this mechanism, we'll be able to achieve traffic optimization and also maintain a stateless core at the same time. Next slide, please. So a P2M chain is a single path tunnel, which can reach multiple leaf nodes along this single path. To reach all the leaf nodes, the root send packets over one or a small set of P2MP chains. So the mechanism is generic. It's applicable to all the topologies. It benefits the most for ring topology and for linear and or semi-linear topology. In a ring topology, as you can see in the picture, first picture, for each multicast stream, we would only need one P2MP chain. In a linear topology, as we can see in the second picture, to reach the 4 leaf nodes on the right, we would only need 2 P2MP chains instead of 4 P2P tunnels. So this significantly reduces the amount of traffic and the number of tunnels across the domain. Next slide, please. Next slide, please. Yeah. So how do we build a P2MP chain? So on a P2M chain, there is one tail end leaf node, which is just a normal receiver. This is the node L2 in the picture. And there may be one or multiple transit leaf nodes on the chain. These nodes are both transit routers and receivers. We call them bot nodes. This is be the node L1 in this picture. So on node L1, for each incoming packet P, we replicate it to make a copy P1. We call this a chain replication. And then we forward the packet P downstream along the path. And we process the copy P1 locally as a receiver. So in this draft, we model this whole forwarding behavior of bot node as a new type of segment called bot segment. Its seed is called a bot seed. So with that, we can build a P2MP chain by using a seed list with bot nodes represented by their bot seeds. And this seed list only need to be provisioned on the root node in a similar manner to regular point-to-point tunnel. Next slide, please. So some properties of bot segments. Bot segments are nodal segments on each router. There is one for SR MPS and another one for SRv6. They are global segments. The bot sets are allocated from sRGB. They are routable segments through the shortest path, but they can also use together with other types of segments to build explicit paths. They may be advertised by ISIS, OSPF, and BGP. So bot segments are, very similar to node segments, except that the type of forwarding behavior they represent. They're common and shareable building blocks, forwarding instructions for stateless P2MP tunnels. Next slide, please. So let's look at an example. So in this picture, we have a multicast stream to 4 leaf nodes, L1 to L4. And then we are using 2 P2MP chains, a red one and a green one. The red chain takes the shortest path from root to L1 and then from L1 to L2. So its seed list is very, very simple, which is a B1, which is the bot seed of L1, and then N2, which is the node seed of L2. And the green chain takes a explicit path, to L3 and L4. So its seed list is A1, A2, A3, A4, A5, which are all adjacency seeds. And then B3, which is the bot seed of L3. And then A6, A7 to L4. Next slide, please. Next, please. I'll skip this example. So this is diagram of the generic model of bus segment behavior. We have an incoming packet P, and we replicate it to make a copy P1. For packet P, we perform next on the bus set, and then we forward P based on the next set. For P1, we do a sequence of next on all the P2MP chain sets, and then we process, we receive this P1 locally. Next, please. This is the same diagram in the case of, map to SRMPS. In the case where a packet has an innermost service label, the root need to insert a special purpose label called the end of chain label between the service label and the P2MP chain labels, so that when we, pop labels of P1, we know where to stop, and we can, keep the service label with the packet for local processing. Next slide, please. I'll skip this example of end of chain label. Next, please. So in the case of SRv6, we propose to encode all the P2MP chain sets in a dedicated SRH, so that when we process P1, locally, we just remove the outer IPv6 header and the SRH, and then we process the remaining P1 locally. Next, please. For path computation, a P2M chain is essentially a single path. So P2M chain computation can be, based on algorithm extended from the traditional P2P path computation. This draft does provide some considerations specific to P2MP chain. So, but due to the time constraint, I will not go to the details. Next, please. So we welcome feedback from the working group. In the next version, we plan to specify, protocol extensions for bus segment advertisement.
Thank you, Emil.
That's it. Yeah, that's what I had. Yeah. Thank you.
So we already used the 10 minutes slot. If you can have short comments from the queue. Adrian, please. Adriana?
Yeah, thanks. As far as I understand this, this is doing drop and continue, and there's no forking apart from at the root. Do I have that right?
There may be forking at the root if the multicast stream can take more than one chain.
Right.
To cover all the, yeah.
My question is, there's no forking anywhere else apart from at the root.
Right. Correct. Yes.
Right. So there are some topologies where this really doesn't work well. The simplest one is the inverted letter Y topology, where there's where you would normally consider a point to multipoint fork, but you either have to send two copies down the root of the tree, or you have to return from one of the buds, return back up into the network. So that's while this works really nicely in all the examples you drew, I suspect it falls apart in other example topologies.
This mechanism, as I mentioned in the early slide, benefits ring topology and linear and semi-linear topology. The goal is it won't be able to achieve the maximum ideal, traffic optimization in all topologies. One example will be the example you just gave. But in general, I think we believe that in certain type of topologies and with a certain constraint fed to the path computation, you should be able to achieve a certain level of optimization. Yeah.
Right.
But
Right.
it's
Okay.
not-
That
it's
makes
true.
it that makes it a
Yeah.
useful tool rather than a global solution. That's fine.
Yeah.
Hi, Eamon. Thanks for interesting presentation. Question and comment. Question, why don't you use binding seeds that just local and follow the nodal seed? It's an existing technology. We know how to distribute those labels and seeds.
How do I use the binding seed? Could you be more
You could use
specific?
binding seed as a bat seed just to define function as replicate on lookup, right?
The idea is the same, but but we want it to be routable, just like node seed. So in the simpler case, your seed list can consist of just the bot seed. And you
Yeah, so
bring your
it would be
traffic
great to see
each
trade-off
every.
analysis between using local binding seed while using
Yeah, I
this
think I
technology
have an
versus
example
introducing new
there.
signaling.
If you go to my example 1, you can see that could you go back to the slide?
I think we are short on time. I'll read the draft and comment.
Okay.
The general
Yes.
comment, the computation logic probably should be described in PC, but now you're looking towards something like Steiner tree, right? So I would be really interested to see what it takes to compute most optimized topology for this kind of scenario.
Yeah, sure.
Thank you.
Zafar?
There by mistake, because I was never removed from the queue.
Okay, Yang.
A question for the scale. So if we have like a large number of destinations, so how do we do like a TTL manipulation? So in uniform mode, so any consideration to allow so the train don't like terminate early, and also any consideration of their seed list depths, the label stack depths.
Yeah, that's actually in the if you have a large number of leaves, you probably use a number of chains, and for your path computation, you can specify a number of constraints. One would be the maximum hop count, to limit the end-to-end delay on a per chain basis, right?
Okay, thanks.
So yeah, your maximum hop delay will be derived from the maximum hop count should be derived from the maximum delay you allow in your network, for a packet to accumulate from the root to your tail end leaf.
Yeah. Okay. Thanks.
Okay, thank you. So in general, there is a set of trade-offs involved. It would be good if the draft discussed a bit more those trade-offs. Next is thank you. I don't know, Fan or Zuezong, you are two on the two names.
Yeah,
Fan.
I will present this. Thank you, Chair. This draft introduced the redundancy protection mechanism for the segment routing paradigm. Next page, please. Although it is a 0.0 version draft, it has a history for about 2 years. And we first introduced this work at 104 to the DetNet working group as the SRv6 data plane encapsulation for the deterministic networking. And in the following in following meetings that we proposed this to DENNET 6-man working groups, and the DENNET working group chairs suggest us to move this work to a spring working group because for the supervision, since we are making the new extensions based on the SRv6. Okay, next, please. We think that redundancy protection is one of the mechanisms to achieve the service protection, and the service protection actually is one of the 3 techniques defined for the deterministic networking. And the second reason we propose this work is there's new requirement for the network and for the services like the cloud AR or cloud games. This kind of services requires more strict RSA guarantee, for example, the end-to-end reliability. So this redundancy protections follows the principle of the pre-auth that stands for the packet replication, elimination, and ordering function that originally defined for the DENNET. And in this draft and this document extends the capabilities in the SR paradigm to support this mechanism. Next page, please. And here is an example scenario for this function. And first, the R1 receives the flows and encapsulate the segments to steer the packet, steer the flows to the redundancy node. And on the redundancy node, the flows are replicated into 2 copies and sent through the different paths to the merging node. At the merging node, if the first correctly received packet will be transmitted to R2, and the second packet, which will be called redundant packet, will be eliminated. And if one of the paths between the redundancy node and the merging node fails, and the service won't be interrupted since we have this redundancy path. And currently the merging node can actually provide the functionality of the ordering, but it is optional. It is defined optional so far. Next, please. Yeah, in this draft we define 2 new segments. One is the redundancy segment and the merging segment. And these 2 segments performs the packet replication, elimination, and ordering function on the redundancy node and the merging node, respectively. And on the redundancy node, the redundancy segment is associated with the redundancy policy, and it will be explained later to steer the flow. And there are 2 new behavior AND-R and M are defined for these 2 segments. And on the redundancy node, there is also metadata to be encapsulated on the redundancy node and remove it on the merging node. And so far the metadata, the flow identification and sequence number are the metadata defined here. One is to identify the unique flow. Another is to identify the packet sequence of one flow. And for the redundancy policy, it is a variant of the SR policy, and it includes the more than one ordered list of segment between the redundancy node and the merging node. And we defined it the last because the redundancy node is actually specifying the path between the redundancy node. The redundancy policy actually is specifying the path between the redundancy node and the merging node. So we assume that the last segment of the ordered list is always the merged segment. Next, please. This page and the following page are the behavior, the suit code for the AND-R and AND-M behaviors. I won't go through one by one or line by line. Maybe we can go to the second following page. There is a figure that I can explain here. So on the I think I will explain more on the redundancy node and merging node. So on the redundancy node, actually we will create two new SRH header, and this headers include will be in the segment list will be encapsulated triggered by the redundancy policy. So the SRH will indicate the paths from for the primary paths, and the SRH will indicate the second paths. And on the merging node, on the merging node, if the packet is not the redundancy packet, and the packet will be encapsulated with a new SRH to steer the packet to the end of the to the end of the path. Yes, and yes, to the node 2, and if it is happens in the other cases, like it's the redundant packet, it will be dropped. Yes, I think that's, yeah. Next, please. Yes, we would like to, because this work is first initiated from the working group, that working group. So here we propose this generalized redundancy protection mechanism to spring, and we would like to expect more comments and discussions and maybe collaborations. Okay.
On.
If you could go back one slide. Okay, in this slide, the redundancy node replaces SRH1 with either SRH2 or SRH3. And since is it possible that SRH2 or 3 are actually longer than SRH1 was?
Yeah, I'd like to. Yeah, actually, I'm very happy to have to explain more on this page, on this figure. Actually, we define this redundancy node and the merging node, or the redundancy segment and merging segment. It defines a pair of segments that. Yeah, I will first answer your question. I think that we define these two segments, and in between these two segments, or between these two nodes, that is the functionality of the redundancy protection. Actually, before the redundancy node or after the merging node, it is just purely SRv6 SRv6 domain. So we would like to split this. If we use this simple case, we would like to split this into three parts. One is the part from node 1 to the redundancy node, and at the node 1, the SRH only indicates the segment list from node 1 to the redundancy node. It doesn't include the other passes towards to node 2. And on the redundancy node, that it will specify the path from redundancy node to the merging node. And on the merging node, it will place the new segment list to the node 2.
So the packet may be longer when it leaves the redundancy node than it was when it entered the redundancy node. Is that correct?
Yeah, I understand. So is there any concern?
Well, yes, it's the same concern with header insertion. If the packet is longer, you may hit MTU problems.
Yeah, yeah, okay, but yeah, I suppose that this is yeah, this is a problem, but maybe this is not a problem that we should. I mean, this is not the scope of this of this redundancy protection. I mean, it's a generalized problem here. Yeah, yeah.
Well,
I
it's a
understand
generic
the
problem
question,
with header.
Mm.
It's a generic problem with header insertion.
Yeah.
But you've hit the same problem by making the header longer.
Yeah. Actually, I'm not quite known about this MTube problem, but I think I will maybe reply you later if I understand the relation between the MTube problem and how we can avoid or solve this problem in our case.
Sure.
Yeah, I think I will reply you later.
Okay.
Thank you.
Thank you.
Issue can be solved by, like, for example, compression mechanisms. That will be another topic on Friday. Welcome, guys.
All right. All right. All right, we are not hearing you. Okay, can you send your comment on the list? Okay, so we are going to cut the queue. We are running a bit late. So we had 3 items on the agenda. 2 are from WIMO, and they are related to the failure of the endpoint of the segment. So we discussed a bit at the beginning of the meeting, and we're going to have a dedicated session for this subject. There are at least 5 or 6 drafts for that subject, or regarding the not failure of the endpoint. So it makes sense to have a coordination between all those drafts and have a dedicated meeting. And given that, we're going to skip the 2 slides from WEMO to gain time and to avoid having repetition for the next meeting. Thank you, WEMO, for your understanding. We have discussed offline. So we have a few minutes for the young model. Maybe we could focus on the first 2 slides, because I don't think there is much point in discussing the detail of the model at this point. And this is young. No, this is I don't know who's speaking.
Hey,
Jagan,
this is
no.
Jagan here. Yeah.
Thank you.
Yeah. So here actually I'm going to present SR segment, SR service programming Yang data model on behalf of our draft co-authors. Can you please go to the next slide? This Yang model is based on the SR service programming architecture described in the IETF draft. Next slide, please. Yeah, this Yang model covers the base SR segment, SR service programming model, which is common for both SR aware and SR unaware services, and Yang model for SR unaware service proxy. Next page, please. This Yang model consists of 4 Yang modules, which are shown in the green boxes. The middle SR service programming model is the base SR service programming model. The bottom green box shows the SR unaware service module, which augments the base SR service programming module. Similarly, any new SR aware services could be modeled by augmenting the base SR service programming module. Next slide, please. This is the base SR service programming Yang configuration model. This is a list of service program indexed by name. The key attributes are highlighted in the red boxes. The first one is like SR service programming behavior. This would be SR aware, static proxy, dynamic proxy, etc. The second one is the service type and service instance represent a service. In the case of SR aware, this is the exact service which is offered, and in the case of SR unaware, service proxy, this is the service which has been proxied for. Next one is the SID assigned or allocated for this SR service programming. The last one is SR service container, which would be augmented by SR aware and SR unaware service specific data models. Next slide, please.
Jagan Babu.
Yes.
Sorry, we don't have time to review the whole Young model in detail.
Okay.
I think the goal of the presentation was to raise the awareness of the draft on the proposition to the working group, but and seek input and feedback.
Yeah, sure.
I think the detail of the Young model could be read from the draft rather than presenting slide.
Okay, sure. Yeah.
So, thank you.
Yeah, thanks.
Do we have comments from the mic? Otherwise, thank you again, Waymo, for accepting to delay your presentation for the dedicated meeting. Also, we have a meeting on Friday, which is dedicated to one draft, which is the requirement from the design team for the discussion and preparation. So please read the draft so that we can have a useful discussion. So thank you for your time, and see you on Friday. Thank you. Bye.